Hey guys, how you doing? This is gonna be the part 2 of the previous video that I did about the most beautiful concept in calculus, the derivative, okay? So let's dive into it. So now, in that video we said that if we have a curve, we could say this is probably x squared, and now we place 2 points, x and x plus h. They have a difference of h units, and then we try to bring these 2 points together to a very infinitely different point. So that means that with a distance between the 2 points that is infinitely small, we're gonna get basically this. Here I try to make the 2 lines of the 2 values that of the 4 values that we're playing with a bit separate so you can see them. But basically what we're doing is that we made h approach 0. So these 2 points, they got very close. So we had them up here and we made them be very close in here. And then the outputs, so f of x plus h and f of x, well, they also got very close because you can see these 2 lines, they're gonna meet eventually at the same point, which is what we have here. Now, a derivative is going to be the function, and what you want to do is basically you want to find the slope of a tangent line. Remember, this is a tangent line, this is a secant line. A derivative is the algebraic expression that you're gonna use to find the slope of any curve in the function f of x. And how do you do that? Well, you simply use this equation that we know. Y2 minus y1 is gonna be equal to x2 minus, well, it's not gonna be equal to, it's gonna be equal to the slope, but I mean, this fraction is equal to the slope of the line. And now, how do you do this in terms of the function? So with these values, f of x and that notation, how do we do it? Well, we know we have an x value that is smaller. So basically, we also know that we have a y value that is smaller than another y value, which in this case would be f of x. And we also have a greater x value that has its corresponding greater y value, x plus h. Now we can simply plug in those values in that equation, considering that we want to make the distance between those 2 points as small as possible. Okay, so basically as h, the distance between the 2 points is approaching 0. So we're gonna say the limit is going to be h approaching 0 in the function, or well, the limit as h approaches 0 in the function. So now we're not going to technically take a function, you could say, but rather a slope. So what is y2? Well, we know it's our greatest y value, so f of x plus h minus what is our smaller y value, f of x. All of this divided by x, our greatest x value, so x2 minus our smallest x value, which is just simply x. Now simply, well, we know these two, positive and negative, they're gonna cancel out, x minus x, and you're gonna get h on the bottom, okay? And now I'm pretty sure this is something that all of you know, or maybe if you Google definition of a derivative, you're gonna find this equation, well, this expression. And now this is basically the same as this, okay? You're going to take the change in the top and divide it by the change in the bottom, okay? Or the change in the y values over the change in the x values. And you're going to make that change happen in a infinitely small interval that is going to be h, but we just want h to be as close to 0 as we can possibly make it. Okay, we just want x to h to be very small, and we're gonna get this. Now this is what we call f prime x, okay? F prime. This tick or this apostrophe is just simply going to mean prime, okay? Or the complement of f of x. So I hope now you see that this is a derivative, and a derivative is not that bad. We say it is a derivative because, well, it is derived from the initial equation or the initial function that you have. So for example, if we say that, we're going to say that f of x is going to be equal to x squared. Now we know that would give us a graph something like this, right? And of course you got the negative part, but I'm just gonna focus on the positive part of the parabola. So now in this case, what we want to do is that we want to find an expression, or f prime, that allows us to find this slope for every x point in the function. So we use this definition. So if we say that f prime, so the derivative of f of x, which is just simply, well, something that we derive from f of x, that's where the name comes from. So f prime of x is going to be equal to the function. So let me wait. So you're going to have, this is going to be equal to the limit as h is approaching 0 in the function. So f of x we know is going to be equal to x squared. Now, if we have, for example, 10 squared and we add 1 to 10, that would be 11 squared. And that's exactly what we're doing in x plus h. So in this case, we would have x plus h squared minus our initial function, which we know is x squared, okay? Basically y1 or f of x, basically the value that we have in there. We're just finding a slope, okay? It's pretty simple. Derivatives, you should not be worried about them, okay? They're pretty cool. And now the distance between our two x points is just simply going to be h. And we need to find this limit, okay? Now this involves clearly using a lot of algebra. Well, maybe not a lot algebra that you should know by now, but you just need to solve this, okay? And now, well, let's do it actually. Now we could expand this, and we could say, well, no, actually, now I need to show you. Okay, yeah, now I'm gonna do the definition actually. So let's solve this. So we're gonna have that. We could take this as a difference of squares, but it's actually better to expand. So we're gonna have this is x squared plus 2xh plus h squared minus x squared. All of this is going to be divided by h. This should be equal to the x's, they go out, and you're gonna get this central part right there. You can take out, now you see a common factor, so you can take it out and you can say this is gonna be equal to 2x plus h divided by h. You know, the h's, they're gonna cancel out, factor in the denominator, and you're gonna get that that limit is gonna be equal to 2x plus h. Okay, 2x plus h. And now the limit is h approaching 0. So basically this number is nothing, okay? We can just simply replace to find the limit. Now we just simply have a limit, okay? As if you were doing limits the first day that you started your calculus class, you're just simply going to substitute h equals 0. So you basically have that for the limit as h equals 0 in this expression. This is just going to be equal to 2x, okay? Which I'm going to keep writing up here, which means that if f of x is equal to x squared, then f of prime or f prime is just simply going to be equal to 2x, okay? This is the derivative, or the 2x is the derivative of x squared. Now you might be wondering, well, and now what the hell do I do with these 2x? That is what we were trying to get, what I said that we needed to find before. We need to find an expression that allows us to find the slope in every x point for a given function. Basically, we need to find another function, because if you want to have a lot of x points, you need to have a function so you can plug in different inputs. And this is our function. We have a different function that is derived, that is why it's called the derivative, from f. And that function is just simply f of x. Now, if you have a parabola, in this case, and well, you have, 1, you have 2, you have 3, you have all the values that you want. If you want to find the slope of the secant line, what you can do is you can just simply say the f prime, or the derivative of x, evaluate it. For example, what is the slope of the secant line at 2? Well, you're just going to say evaluate the function, basically. So f prime of 2 is just simply going to be 2 times 2, which is equal to 4. If you have a parabola that is x squared and you want to see what is the slope of the function at x equals 2, that slope is going to be equal to 4, okay? That means that you have a line in this case that is probably going to go something like this. It's going to be kind of steep. You would go something like this, and that means that you're going to move in the x values, you're going to move 1 unit, and in the y values you're going to go up 4 units, okay? That is what this slope right there would actually mean, okay? Now this is what a derivative is. It's a pretty cool explanation, and I think it's just clever. I mean, I would have not thought about bringing 2 points together and using a limit to express that slope in that instant, in that infinitely small instant. I think that's something Leibniz and Newton, well, they were pretty freaking clever to think of that. I don't know. I mean, I think that's so cool. So, well, this is a derivative basically, okay? You're just finding a slope. And now clearly, basically, the applications of these clearly are just huge. I think they're basically, you can say they're infinite applications. In physics, you can go to the most advanced physics and you're gonna find derivatives, okay? It's pretty cool that there are vibrational derivatives. You can find fractional derivatives, higher order derivatives. Don't worry about those names, but let me just tell you that it's pretty cool. So basically that is what a derivative is, okay? So I hope you guys enjoyed this video. Know a bit more what a derivative is. Maybe go back and check what I did. If you don't have it that clear for now, like by now. And well, I hope you guys just enjoy everything, okay? I really like this. I really like derivatives. I think that it's when calculus starts getting fun, okay? So well, I hope you guys enjoyed this video and see you in the following one.